Solar panels are an incredible innovation in energy tech, but they're way less efficient than they could be because they have a problem: heat. Specifically, waste heat, or energy that's lost while converting the sun's energy into electricity. But new technology made possible by carbon nanotubes may be just the thing that brings solar panels into the lead for energy technologies, which would be sweet. In brief, a solar panel works like this. The solar cell is made of a semiconducting material, like silicon, that's had some other differently charged elements added to create an internal electric field. When the photons from the sun bounce down and hit the solar panel, they knock electrons off the silicon atoms, and those electrons can then be pulled into an external circuit as electricity. So there you go, sunshine into power. But not all of the sun's rays that touch a solar panel get turned into electricity, and this is because not all light is created equal. Electromagnetic radiation, of which visible light is a part, is a spectrum of many different wavelengths, and only certain wavelength photons carry the right amount of energy to knock electrons loose. For the rest of the wavelengths that can't displace electrons, that energy is lost, unable to be used in a solar panel to generate electricity. We actually lose about 70% of the electromagnetic radiation that hits a solar cell because of this mismatch in energy levels. This is one of the biggest issues facing solar panel efficiency, and this, paired with other long-standing problems like the resistance that electrons face when passing through conducting materials, makes scientists think that in the future, even with improvements to the existing tech, we're looking at a maximum peak efficiency of solar panels at 29%, which seems pretty low, to be honest. I mean, come on, sunlight is free. Surely something can be done about this. Well, one rescuer comes in a surprisingly tiny package. Researchers at Rice University are adding a film of carbon nanotubes. When looking at why solar panels lose so much energy, the researchers behind this new tech saw that the radiation from the sun that couldn't be absorbed by the solar panels was bouncing off as heat, and they wanted to harness it. But how to turn that heat into electricity? Thermal radiation, like the kind released by solar cells, is broadband, which is kind of messy. Converting sunlight into electricity is only efficient if the emissions are in a pretty narrow band, which is nice and precise. So the researchers created wafer-thin films of carbon nanotubes that can absorb that broadband waste heat and channel it into narrow bandwidth photons that can be easily converted to electricity. So instead of going from heat to electricity, the nanotube film makes the conversion process more efficient by taking that energy from heat to light to electricity. Nanotube film is also a perfect material for this because it can withstand temperatures up to 1700 degrees Celsius, so it's not going to buckle under the heat. And this is huge. It doesn't require a change to the fundamental makeup of solar panels, so it's minimally disruptive to existing solar infrastructure. And the researchers say that their tech could theoretically increase the efficiency of solar panels from that measly 29% efficiency maximum all the way up to 80%. We live in a world where we're gravitating more and more towards renewable energy, and we need to. But solar energy, this hugely untapped energetic resource, currently only produces around 2% of the world's electricity. Potentially huge leaps in solar panel efficiency could make so much more of the sun's energy available for use. The project is still in the prototyping phase and is a ways out from being used in existing technologies, but if its promises come to fruition, it could change the way we think about the future of our energy grid and how efficiently we can power the world with clean energy. Big news. If you want even more on how solar panels are adapting for the future, check out this video over here on solar cells powered by bacteria, and subscribe to Seeker for energy tech updates as they break. Let us know what other developments you want to see us cover down in the comments below, and as always, thanks for watching.